The last section of our 3D figures. This is going to be the similarity of some similar 3D figures, and then we're also going to throw in a little bit of displacement and density. So let's start off with an investigation. It says find the surface area and volume of a rectangular prism that has the dimensions of 2 by 3 by 4. Okay, I like to see a visual of this, so let me get my pen and I'm going to draw in a rectangular prism that is a 2 by 3 by 4. So 2 by 3, we're going to just say feet by 4. Okay, so volume first. The volume is capital B times 8, so area of the base, which is 3 times 4, and then times the height, so that's 24 cubic feet. Okay, so there's the volume. Let's now do surface area. So surface area, remember the formula is capital P times H plus 2 capital B. So perimeter of the base is 6 and 8, so that's 14 times the height is 2 plus 2 times area of the base is 12. So what does that equal? 28 plus 24 . So 52 square feet. All right, so did that. Now step 2, it says if the dimensions of this prism are doubled, what happens to the surface area and the volume? So most people would say, oh, I bet the volume has to double as well as the surface area. Okay, so now we're going to go ahead and investigate that. So let's draw a larger prism. And remember, now it's being doubled. So this is going to now be 4 feet. This will be 6 feet, and that'll be 8 feet. So let's start off with the volume. The volume is area of the base times the height. 6 times 8 times 4. So that's 192 cubic feet. That clearly did not get double because double 24 is 48. All right, and we did the volume formula right there. Let's do surface area and then we'll investigate how these numbers change. So surface area is perimeter times the height plus 2 capital B. So perimeter of this one is 12 plus 16, 28 times the height plus 2 times area of the base, which is 48. So 28 times 4 is 112 plus 96. So 96 plus 112 is 208. And this is square feet. And that clearly did not get doubled because 52 doubled is 104. But 208 is related to that. So the question is how did it change? Because that's what we need to investigate. What happens here? So the volume did not double, okay? This surface area down here did not double. So we're going to write down the ratios of what did happen, okay? So let's start off by writing the side ratio, okay? The side ratio, I'll put way at the top. The side ratio is 1 to 2, okay? Because that's what happened to all the sides. The sides got double, okay? 2 to 4, that's 1 to 2, okay? 3 to 6, 4 to 8, 1 to 2. So now let's talk about what happened in the volume now. So what is the volume ratio? Well, the volume ratio went from 24 to 192. How many times does 24 go into 192? 8 times. So this actually reduces 1 to 8. So that's our volume ratio. Okay, let's do one more. Let's do the surface area ratio. So the surface area ratio went from 52 to 208, which that one is 1 to 4. Okay, so I'm going to highlight all three of those and see how they're all related. So 1 to 2, 1 to 8 is the volume, and 1 to 4 is the surface area. Now, y'all studied on our last unit how the areas changed of similar figures. And so the areas change of similar figures by just squaring the original one, which is true here. If I do 2 squared, that equals that 4 right there. So how do you think the 8 comes into play? It's when you cube 2, okay? So the volume ratio is kind of like saying 1 to 2 cubed, okay? Okay, or really 1 cubed to 2 cubed, because 1 cubed is indeed 1, okay? And same thing here. So they are all related. And so what I need you to remember here is for the side ratio, if it's A to B, then the area ratio is A squared to B squared, and the volume ratio is A cubed to B cubed, okay? And we'll use these ratios later on in a couple of examples. So whenever you're looking for the sides, you got to use this ratio. If you're ever solving for an area, you got to use the area ratio. And if you're ever solving for volume, you have to use the volume ratio. All right, let's look at a couple of definitions. Displacement. Okay, feel free to pause the video. Displacement is the volume of fluid that rises above the original fluid line when a solid object is submerged into the fluid. Okay, so that's displacement. Density. Density is the ratio of the mass of an object to its volume. So I'm pretty sure that you did this in science. We'll do a little bit of that. And we're just going to work with that just because it involves volume. And that's what we have been doing, volume. So density equals mass divided by volume. So let's try a couple of examples, and then we'll do some examples, a couple of examples with similar figures. So it says, when you put a rock into a container of water, it raises the water level of 3 centimeters. If the container is a rectangular prism whose base measures 15 centimeters by 15 centimeters, what is the volume of the rock? Okay, so this has to do with displacement. So I'm going to draw a container. Okay, and imagine the water is about right there. Okay. All right. And then you drop in a rock in there. And then it says the water now went up to 3 centimeters, went up 3 centimeters. So now it's up here. Okay, so it's further up. And so the water level rose 3 centimeters. So from there to there is 3 centimeters. Okay, so from there to there is 3 centimeters. Okay, so the way you figure out the volume of this rock down here is you find the volume of that rectangular prism that it rose. And so all you do here is you would do the base, area of the base, times the height that it rose. Oops. Okay, the height that the water rose. So we're going to do 15 times 15 because that's area of the base, and then times 3 because that's how much the water rose. And that's going to give you the volume of the rock because that's displacement. So that's 675 cubic centimeters. Okay, that's the volume of Okay, so displacement. Try one more. It says, what is the mass of a solid block of aluminum if its dimensions are 4 by 8 by 20, and then it says the density of aluminum is that. So let's write down our formula. Our formula is density equals mass divided by volume, okay? And so the volume of this block of aluminum is 4 times 8 times 20. And then that right there is going to get plugged in to the formula. And then we know the density that'll get plugged in to density. So we're going to write 2.81 equals mass over 640, because I just multiplied 4 times 8 times 20. Okay, and so that's centimeters cubed. And so how do we figure out the mass? All we do is multiply by 640. Whatever that is, that's our mass. So 640 times 2.81. It is 1,798.4 grams. Okay, because the centimeters cancels out with the centimeters, because this is grams per centimeters cubed. Okay, and so this is the mass of the aluminum block. Okay, let's try a couple of problems that deal with similar figures. So it says the surface area of a pyramid is 42 square inches, and then a similar pyramid has a surface area of 379 square inches. How much larger would the volume be of the bigger pyramid? So we have to see how these two compare. So we have a small surface area, and then we have a large surface area. So let's see if what that reduces to, because you always want to check to see how many times, because it can be reduced. So 42 divided into 379. 9.02, so very close. I bet you that really should have been, to make this a nice pretty number, that probably should have been an 8, just to make it a little bit better. So let's change that to 8. Okay, so that way the numbers don't get too crazy. So that's an 8. And so that really should be 1 to 9. So what I just wrote down right here is the ratio for what? For area. So that's the surface area ratio. Okay, but I want to know how many times bigger the volume would be. Okay, well, the area got 9 times bigger. Does that mean the volume is going to get 9 times bigger? Let me refer back to this. Okay, just because the sides got bigger by twice the size, the volume did not get twice as big, neither did the surface area. Okay, so everything's different. That's why I highlighted those 3 ratios. So if I go over here and the area ratio is 1 to 9, okay, what would the side ratio be? The side ratio would be the square root of that. So the square root of 1 is 1, and the square root of 9 is 3. So that's your side ratio. So all the sides got 3 times bigger. That's not what they're asking. They're asking how much larger would the volume be. So now let's consider the volume ratio. What do you do to that? You cube the side ratio, just like we saw in the original example. So 1 cubed is 1, and let's not, I know we have a lot of examples that are 1 to number, 1 to this, 1 to that. Sometimes it can be 2 to 3. Sometimes it can be 3 to 4, okay? So just because it's always 1, you do not need to reduce it. You can leave it in that form right there, okay? But so 3 cubed is 27. So 1 to 27, so the volume's going to get 27 times larger. Okay, so just because the surface area got 9 times larger doesn't mean that's how many times larger the volume is going to get. Okay, so 27 times larger. All right, let's try one more. So it says the volume of a triangular prism is 192 cubic centimeters volume. And then the volume of a similar triangular prism is 275 cubic centimeters. If the surface area of the larger prism is 360, then what is the surface area of the smaller prism? Okay, so I'm going to tell you right now, here's what a lot of you guys are going to want to do. 192 is to 275 as x is to 360, and then you're just going to cross multiply. Okay, cannot do that. Okay, for 192 is centimeters cubed. And so is that one. This is centimeters squared. You cannot put a ratio with different units in the same proportion. Okay, so we have to break down and solve for the area ratio in order to solve this problem. Okay, I do want to look at this ratio right here though. Okay, so let's see if that reduces. You always want to check to see if you can reduce it. So 192. Usually you can just use your calculator to reduce it. So let's see, 190, I'm just going to divide by, no, I don't want to divide by 2 because the bottom one doesn't look like it can reduce. What does 192 reduce to? No, stop. Let's see. Let me go find my other calc. Okay, so I figured out the problem. It wasn't 275. It was 375. So that's why it was kind of difficult to simplify here. So, you know me, making mistakes like always. All right, so now let's try and reduce that. When I reduce that in the calculator, that reduces to 192 divided by 3, so 5. 64 over 125. Okay, so that right there is our volume ratio because those are our two volumes. Okay, 64 to 125. And I'm pretty sure that doesn't reduce because I just tried to reduce it in the calculator. Okay, and so 3 goes into both of these. All right, so I'm dividing 3 into that and divide 3 into that. Okay, and so that's how I get 64 and 125. So if I'm solving for the surface area, I can't use the volume ratio. I have to use the surface area ratio. So what I need to go through is I need to go through and find the side ratio, because then once I get the side ratio, I can then solve for the surface area ratio, and that's the ratio you have to use. So if that's the volume ratio, what you need to do is you need to cube root these two right here. So you have cube root on your calculator on your iPhone. If you have a regular calculator, you can do it there too. So the cube root of 64 is 4. And the cube root of 125 is 5. So this right here is our side ratio. Okay, so all the sides are 4 to 5, 4 to 5 of this triangular prism. So imagine a small triangular prism and then a larger triangular prism. And let's just say the base was 4. That means this base over here was 5. Okay, because those are the side ratios. Okay, the volume ratio is 64 to 125. So now, in order to solve for the surface area, I need to use the area ratio, which would be 4 squared to 5 squared. I have to use that. I can't use 4 to 5. I can't use 64 to 125. Now you can write your proportion. The larger one is 360, and this is centimeters squared. And think about it, you're kind of in square units over here. Now we can cross multiply. So 4 squared times 360 is 5,760, and then equals 25x. I'm going to divide by 25, divide by 25. So 5,760 divided by 25 is 230.4. 230.4. And so that is the surface area of the larger. So we want to write centimeters squared. So here's my answer right here, my surface area of the larger prism. So the main thing you need to remember is I'm going to highlight this. You have to use the area ratio when you want to solve for a surface area. Okay? Now, if they give us the volume ratio, you got to know how to work your way to the side ratio and then use the side ratio to get the area ratio. So you'll have some problems like this on your homework.